Hello everyone and welcome to this session on projects using TCLTK for Hypermesh. Let's start with what I have in store for you. So as you all might have a generic idea as to what we are trying to do here in this section called projects, we will be doing a few exercises on Hypermesh. These exercises will include building up of macros using TCLTK, which are the two programming languages used to build Hypermesh essentially. So in this very short PPT, I will let you know about how we are going to progress with these projects. So let's get started. So first thing is, how is all of these projects organized for you? So what I've done is I have a sort of a life cycle of a CAE project that I have considered. All the typical milestone activities that happen during a CAE or a meshing activity are highlighted as different exercises. These exercises I will first do manually, and then we will try to think and build upon a logic by which we will convert this into a macro. Lastly, I would also like to emphasize on why or what should be your lookout while you are looking at these activities. So let's assume that some of you might already be a CAE engineer somewhere, or some of you might be a fresher who is going to enter a CAE field. So typically you will be put into two major roles. If you are starting your CAE journey, most probably you will be a meshing engineer, or if you are little experienced with meshing and model building, you will also be a reviewer. So all the macros that we will try to cover here are sort of catering to the needs of these two roles. Okay, so in the next slide, I will show you a list of CAE activities that we are going to look at and the different macros that can be built at them. Just imagine this, that you have a model. Given CAD model comes from the designer. Then all you have is a blank Hypermesh window. So let's take it from there. Okay, so your first step will be CAD import. Then upon CAD import, it is not necessary that only the important parts from a meshing or a CAE perspective are imported. There will be other parts as well which are not really that important, and you will have to take care of those parts because they will unnecessarily increase the size of your Hypermesh project or your Hypermesh file. And as you can understand, most of you will have decent machines, and yet you will have to keep clearing the clutter in the .hm file, which is why model cleanup and isolation is also very important. So here we will build our first macro, which is the model cleanup macro. What it is and what should we do, stuff like that I'll explain when we actually start building it up. After this comes the important part of meshing. As you know, meshing, we can't really build a macro to mesh a component because all your typical CAE softwares, be it ANSA, be it Hypermesh or some others, they've already been working at some pretty elaborate macros to do that, to essentially completely automate the meshing process altogether. Nonetheless, once the meshing is done, we will have a few macros that will help us to either resolve the issues in meshing or maybe make it better, or also sometimes just to make the reviewing of the mesh a bit easier. So these two macros that I have mentioned here is something that comes into play. Next is the element quality. So we will have a quality check tool. So by quality check tool, what I mean is you specify the quality criteria. The tool will simply isolate the elements that have those quality criteria failed. Yeah. After that, we will have the thickness assignment. So as you can imagine, your part is meshed, the quality is great. Now finally what remains is the thickness and the material assignment. So that is where the thickness assignment macro comes into play. Now you might also have a question as to why do we need a macro to do that? So we'll talk about that when we actually start building it. Finally, we create a final deliverable file. What I mean by deliverable file is a .fea file. So it could be from a different deck, maybe PAM Crash, Abacus, Nastran or whatever, but it has to be delivered in a particular format, taking into account a few guidelines. So those guidelines are what we are going to try and put into this final macro, which is the clear compress macro. So all in all, that is the activities that we are going to do. And as time permits, we will either mesh different number of components, or we will just proceed with one single component for all of these macros. Now comes the most interesting part for you all, which is the sort of the visual idea of what we are trying to do. So here, as you can see, this is a lever assembly or a lever pedal assembly. I've chosen it out of random just because I found that the lever here has a lot of rib structures and all of that for us to play with. So yeah, it's going to be pretty good to mesh and also test the different macros that we have. So what are we going to do in general? We are going to import this geometry and clean up the model. Then we are going to isolate the lever and save it as a separate .hm file because we are just going to work on that lever. Then we are going to look at different approaches to, sort of mesh this component, because that is the first step in animation process. Then finally, once the mesh is ready, we are going to check this part on these following rounds. One is geometry capture, next is free anti-edges, normals, quality criteria, thickness, so on. And as mentioned before, finally we are going to create a deliverable file. Now this is what a normal hypermesh activity would look like. But as I mentioned, this course or these projects, they are not upon doing stuff in hypermesh. It's about writing macros in hypermesh that make our lives easier, right? So most importantly, what we are going to do is we are going to create macros for most of these activities and ponder upon the ease of use and time saving that these automations offer. Yeah, finally, most of you will have a doubt that, okay, all of this is fine, but what do I need to begin with, right? I mean, yeah, we are going to do a lot of stuff, but what is the prerequisite? So that is what we have here. The attendee, that is you, has to have a basic understanding of hypermesh workflow and GUI. And I guess since you are opting for these projects, this is something that you will have. Secondly, the attendee has to know the basics of TCLTK programming language with respect to hypermesh. So this I'm a bit dicey about. I'll try to cover it for the sake of the project or based on the scope of the project, but we are not going to go into extreme details of all the commands, okay? Because this is not a teaching course, it is more of a on the fly, a work on the fly course. All right, so here we are on the hypermesh window. What you see is hypermesh version 2020.1. So interesting thing, initially hypermesh versions used to be named as 13.0, 14.0 and so on and so forth. But I think since 2017, they started naming their versions as per the year because that became much easier. Anyway, so that was a little bit of a background. Now let us, sort of quickly talk about the GUI for hypermesh. I'm not going to go into much details because I guess most of you already know about it, but still for the sake of completeness, let's do a quick walkthrough. So here on the left hand side, what you see is your import export toolbar, save, open model, new model, so on and so forth. These three dots represent a .hm assembly, and these sort of icons that show a mesh indicate that it is an import export of an FEA model. Okay, then here you have the view settings, zoom, then the different views, front, top, side, isometric, etc. Here again you have different kinds of zooms, so on and so forth. Then here, let's not go through the details of each and every tab here because that will take unnecessarily a lot of time and might create confusion. Utility is something that changes with the deck that you're using, and you might want to check this out because sometimes they can be really handy. So for example, I think when you are exporting an LS-Dyna model, you have to ensure that there is no temp node in your model. Otherwise, that creates an error with the solver. So you can, sort of just hit clear temp node here and get rid of it. Yeah, anyway, so it's just an example of what you might have find there. Similarly, you have the mask page, which right now is loading. So here you can show and hide different sets of entities, rigids, springs, 1D, 2D, 3D elements for mesh. For geometry, you can hide points, lines, surfaces, and so on and so forth. So yeah, even this can come in handy at times. Lastly, the one that we mostly work with is the model. So that's there. Then you have different pages here. So geometry page, 1D, 2D, 3D, analysis, 2D, post, etc. So as a CA engineer, what I've been always told and what I've found is Hypermesh is something that, the one who's using Hypermesh, he doesn't really rely much on the GUI, because for most of your activities, you use keyboard shortcuts, and all of these keyboard shortcuts can be found here under the preferences section. Under preferences keyboard settings, you can find a ready-made map of all the things that Hypermesh has already done for you. I recommend that you do not change the defaults, at least for the function keys, because wherever you go, these function keys are going to be there, and the sort of mapping to those function keys is going to be the same. So if you sort of do your own mapping for it, it won't be of much help. So you have, for F1 you have call help, F2 is delete, F3 is replace, so on and so forth. You can check it out yourself. So yeah, that's there. And then now, without wasting any more time, let's get started. So I think you already remember the assembly that we talked about, the lever assembly. And so this is how we are going to open it. You can either go to the traditional way of hit the open, then, browse to the directory, select the file, so on and so forth. Another interesting way that Hypermesh does things is, here's that assembly. I just say Control C. I will hit the open button, and I'm just going to say Control V. So as you can see, the dialog box has automatically pasted the path of the file here. I'm just going to say open. Keep looking in the lower left hand corner. You will see what all stuff Hypermesh is typically doing. So yeah, this is how our model looks like right now. Interesting thing to note is right now it has been loaded in the wireframe format, and that is completely intentional, because if I had pressed this button here before loading the model, what would have happened is there is something known as a faceting operation that happens in Hypermesh, which takes quite a while if your model is huge. So instead, what I did is I loaded it in the wireframe format because it loads faster that way. And now I can just, simply isolate the part that I need and get rid of the others. Okay, so let's have a look at what we have. We have an assembly. Let's call it lever assembly instead of the socket. Yeah. So we have the assembly, then we have these different components. As you can see, I have already renamed these parts so that their IDs match with the part name. What I'm going to do is I'm going to spoil it a little. Yeah, whatever. Yeah. The reason why I'm doing that is because sometimes this is how you'll find your files. So most of the names that you see here, they come from the file exchange formats that we have. So you have a STL format, you have different CAD formats, Parasolid, CATIA, so on and so forth. Sometimes during these interconversions, these part names are lost and you get some weird looking part names. Okay, now as you can imagine, sometimes it so happens that there won't be just one person who is going to sort of work on this complete part. The meshing task is going to be divided into multiple people, or even for the sake of, organizing your stuff, names like these are never appreciated. So as a first macro, what we are going to do is we are going to sort of create some quick tools to help us clean this model. So what do I mean by clean this model? Let's first have a look at what we have here. So yeah, we have a symmetric model where we have just one major component, which is this lever. Apart from that, these brackets and all, it's a relatively simpler components. Now, if you are aware of how a CAE process looks like, you will know that these nuts and screws that we have, they are something that we never mesh, including these springs, because we have some different kinds of elements that do that for us. Yeah. So now if I really sort of isolate the parts that we are going to mesh in this model, I'm going to press D. I'm going to go to geometry. Then I'm going to press shift and left click. So yeah, whatever parts those rectangle is going to cut, they are going to be hidden. So in my opinion, these are mostly the connection parts. We also have this part here, so let's hide that as well. So now we are going to say reverse. Yeah, so these are the only parts that we need to mesh. Now, since this model is pretty small, it's okay that whatever we do is fine. But imagine if your model is huge, then deleting these unwanted parts from your model is going to be a huge help, because, as the time progresses in meshing, you are going to create multiple files. Yeah, so that's one of the other things in industry that, typically while meshing, people don't just keep on saving. They always do a save as, because if in case you miss out something or there happens some problem with the file, you always have some previous timestamp to start, right? So yeah, that is the generic idea of what we are going to do. Plus, another thing in model cleanup is sometimes what you also have is this. So sometimes you will have some unwanted points, as you see here. So this green point that you have. So sometimes that is there. Then you have some unwanted lines, unwanted surfaces. So let's create those unwanted surfaces a little later. So yeah, what are we going to do in model cleanup? We need to delete these points. We need to delete these unwanted lines. We need to sort of isolate just the components that we need. And then maybe we also need to rename these components. If the names are proper, we need to renumber them. So for example, if I just go to renumber, let's say some random number, we're going to, yeah, so yeah, everything is renumbered, and typically you will find some random numbers here based upon, at what point do you import the model and so on and so forth. So one of the steps in your model organization is also going to be reordering and renaming the parts. Yeah, so all of these activities we are going to perform once manually, and then we are also going to do that using a macro. That is going to be our first beginning step, because it also forms a good basis to start building stuff up. Okay, so I'm going to restore this model to how it was before. Yeah, so now we are set. Let us once save this thing. Yeah, you can read the stuff here. So file has been saved.